viewers, we discuss today the nature of infinity and different properties and some of the FAQs. Sometimes these questions arises and came into minds always, and some of the confusion created. And I discuss today some of the idea, and in few videos I discuss the FAQs of infinity to clear the doubts, all doubts in minds, how infinity works for and what are the important properties. Let's watch this video till the end. Here if we suppose to consider domain of definitions and let's watch a function. Suppose if we consider that 1 by x minus a, x belongs to R, and if we watch at x equals to a, we get the point 1 by 0, that is not defined. So undefined case 1 by 0, and it is tends to infinity, but except this 0 point we are taking here some of the cases, that is cases of outside this point. It is called the singularity, and we find this topic as a singularity, and if we taking as a limit as x tends to a, 1 by x minus a, it will be certainly it takes to infinity. That's a limiting case. Limiting case is goes to infinity, and 1 by 0 case, that is undefined. So outside the a point, so a defined outside, x defined outside a, so only case is here we write x is not equals to a. So this fallacy comes, x is not equals to a, and if we are taking this limit, we are getting infinity, infinite region we find. But outside that a, we define this function, whatever may be the value of x except a, we define. So it is called the domain of definition. If we consider another function x minus a, x minus b, then and another is x minus c. So if we take it as fx equals to this, and suddenly here also if we take as x is belonging to the real number system R, so here also x is not equals to a, b and c. Outside that we define this result, and any of this point if we are taking this limit, we are taking that tends to infinity. So if we testing it, limit extending to a fx, and certainly that will be 1 by 0, that will be certainly tends to infinity, limiting value is tending to infinity, or a tending to b or c, whatever may be it is. So all goes to similar cases, we are taking corresponding infinity. Now we are going to the practical situation. What happens if we take x minus say 3? Here also we understand x is not defined at 3. This type of result, if we take it as fx, x is not equals to 3, okay, it's okay, no problem for that. But if we testify it, what happens there? And if we take it as a cases, we are getting very large number, and we are taking the some of the definitions. If we take different type of state that are outside this point 3 and neighborhood of 3, if we consider like 3 point at x equals to testing at 3.001, what happens there? Then f of 3.001, and this result goes to 1 by 0.001, it will goes to a higher result, 10 to the power minus 1, 2 minus 3, so 10 to the power 3, that's a bigger result. And if we take x equals to 3.0001, that's 2 naught is extra, So certainly it will be 3.401, and that will goes to 0.000401. So it will goes to 10 to the power 5. So huge result. That also goes to infinity case. Infinite cases symbolizes endless result. And outside this point, we finding these infinite cases. But if we watch at fx equals to x by x minus 3 for testing x equals to 2.999, then certainly goes to 2.999, and that will be negative of, that is a 2.999 minus 1, so 0. So it will be negative of 0.1. So that will be minus of 1 to 3, 10 to the power 3. And similarly, f of 2.49, that will goes to minus of 1 by 0.0001. So it will be minus of 10 to the power 4. So all goes to our negative side of infinity, that is the minus infinity cases. But we only considering without sign, only infinite cases we consider without checking the sign, because this is a discontinuous type of function and some of the continuity grows, but this is a case sensitive cases. Case sensitive means some constant is applied. If we are applying some constant, but we are finding here some of the continuity, and that's why some of the branches come when we are confirm a mathematical way, we are finding different type of branches to study the continuity. But this is a different topic, I don't discuss it today, but I only consider here the observation of infinity, how will it works for. I don't want to discuss here the cases of continuity, whatever may be the continuity or discontinuity cases. And I discussed today how infinity works without sign, and it's a clear cut, it's nothing but observations of infinity, how this comes. So with the help of some function I discuss some of the idea, but in detail I will discuss in my videos, next videos. And if you like this video, like it, share it, and always watching. Don't forget to subscribe the channel. Thank you.